On Tuesday's lecture, we go over data representation. Even humans understand in the decimal number. But remember, in computer, we only save as the binary value. So we talk about in the binary value, you can either have signed integer or unsigned integer. And also your integer depends on the size, the value of your integer, how big it is. You can give them the specific storage size. So we won't waste too much storage. So that's how to represent numeric data. To finish data representation, the last one we want to talk about how to store the character storage. Remember, if we want to store the number, we can just convert the decimal number to the binary number. But sometimes you want to store a string or a character. So that's why we need to understand how to do the storage, character storage. To talk about the character storage, we need to understand computer actually only store binary data. So that's why if you want to store a number, for example, you want to store integer 255. So your 255 actually is a decimal number. 255 in decimal number, so sometimes we have the D at the end that represent decimal number. So decimal number actually equal to, right? So we have binary 1 byte. So that's why here the decimal number can represent all 11111 in the binary system. So then we need to have 1 byte to store the value. That's for the numeric number. So when the character storage, we still only can store the number. But instead, we create a character set. So this character set is what? We have a mapping table to match. For example, if you have the capital A, they have the corresponding integer value. So that's why we have the character set. No matter what kind of character, we have their corresponding integer to represent the character. In early time, character usually we're using the 8-bit. So now actually, even in the C++ code, before you know the C++ code, remember when we have the byte, right? The byte usually we used to represent a letter, a character. So that's we have 1 byte. So in early time, character set only use 1 byte. That's 8-bit. But later on, actually in Java, the character we're using the 2 byte. So that's what we'll see here. If we only use the 8 bits for 1 byte, remember earlier we told you before, right? If you have unsigned integer, because we don't need a sign for a character value. So when we're using the unsigned integer for 1 byte, the range is between 0 to 255. So that's why before, when we have early time, we're only using the 1 byte to represent a character. So that's 8 bits. Actually, they have the 255 number we can use. So that we call the ASCII table. ASCII table actually is one mapping from the character to the corresponding integer. So they have the standard ASCII value for the first half, the 1 byte. Then we have the second half extended second half to fulfill the 1 byte. So simply we just see here, this one actually is the ASCII table. And this ASCII table actually is only start from 0 to 127. So you can see here they have some special character. And the most important thing, they have the character number 0 to 9. They have some operator, and they have the uppercase A to Z and the lowercase a to z. So this one is the standard usage for the letter we need. So those ASCII code actually is occupied from the first half 1 byte. So we call that the standard ASCII. So then continue, you can see the extended ASCII. So they will have more value, the other 127 symbol. So you can see they have some special symbol for different language. They have some special symbol maybe for the math. And you can see they have some Greek alphabet, Greek letter, or those mathematic symbol we need to use. So that's why you can see here they start from 128, so all the way to 255. So that's the ASCII table you can refer to. And also using the ASCII table, we can mapping the value. So did you remember before we always told you uppercase A is ASCII value is 65. So how we see that? So when we see the A, you just need to go up to see, okay, that's the decimal value 64. But just mean start from 64. So actually it's the at symbol is 64. Because 64 plus 0, that's the at symbol. So then if we want to find A, you need to go here to see how many additional value we need to add to the 64. So that's why you can see capital A will be 1 plus 64 is 65. Then did you remember we say the lowercase a is 97? So the same thing, we know we start from 96, but they need to add 1. So that's how we got the 97. So that's why here you can either using the character to find the corresponding ASCII value, or from the ASCII value you can find the corresponding character. So these two tables we show you for the ASCII table. That's for the early time. Actually, even for the now C++, if you have 1 byte character, we follow the ASCII table. And the other one we call that the NC set, NC character set. So that's just different symbol, letter symbol. Then that's the old time we use in 1 byte. But then later on, because the computer can run on different language, so in the screen monitor, we want to display all different kind of the character, all different kind of letter, because the letter in the Latino world, they may have A, B, C, D, E, F, but they represent differently in different language. And also for the Chinese or Asian language, we're using the Chinese character. So those characters, actually, we have a lot of character to represent. So to extend this 1 byte only can allow 255 different value. Then we extend to 2 byte will be the 16 bit. So 2 byte to the 16 bit, remember the value we show you in the unsigned world. 2 byte we will up to the 65,000 something. So that's why when we're using the 2 byte, then we call that a Unicode character that we can support for multiple language character usage. So after you understand that, so for example, if we have, earlier I told you, if you have 255, if this number is just a decimal value, you want to save the value in the 1 byte location. So that's why here we save the binary number. But one thing is, if we want to save capital A in the memory, actually they cannot really store capital A. Remember, computer only have 0 and 1. So the first thing we need to convert ASCII value for the A is 65 in decimal. Then, right, so 65 need to convert into the binary number. So then we have 65 is 64 plus 1, right? So then you can see here, this value is 1, 2, 4, 8, 16, 32, 64. So that's why 64 is the next bit. Then continue, 64 plus 1 equal to 65. So then you see you want to represent capital A actually in the computer. You need to convert to the equivalent ASCII value. So then here is really in the memory how they stored the value. So that's why you can see here, actually for the capital A, we just store 65 in the memory. But when you want to represent this value into the monitor, we will still read this 65. But when you display in the monitor, we will specify I want to display character, right? So did you remember before? Okay, so here I just show you, for example, the C++ code. Did you remember before your C++ code, even you have the integer x, okay, equal to 65. I just want to show you, actually we store the value is 65. But one thing is, can I display this 65 in character? Right, so when we do the cout, right, you just need to do the casting. So then you cast this x value. This x value is integer. But when I do the cout, I can do this value. So then I want to display in the character format. So that's why they will know they want to display the character format. They were using this value to find the ASCII value, then they will display A. Yeah, so that's how before, remember, sometimes your integer and the character variable, they can do the calculation together. But one thing is they also can, according to what kind of data type you want to display, they will display differently on your screen. Yeah, so continue, you can see here, when you do the character set, the Unicode, they have different format we're using differently. But that's according to the language you want to write and operating system. So then one thing is, remember when we're using the ASCII table, you know how to use the ASCII table, right? So even sometimes I want to save the string. So even your string is A, B, C, 1, 2, 3. But remember in C++, we told you string is character array. So they just have one character A, one character B, one character C, and one character 1, 2, 3. So they have 6 characters. So each character store 1 byte in the memory. So that's why here A is 65, B is 66, then 67 for C. But here you can see, remember when we're using the numeric number, those number afterward they will have, sometimes they will have B or D or H. Also here 41 actually represent the hexadecimal. So the same thing, even I have 1, 2, 3, right? But 1, 2, 3 we store as the character. So they won't store 1 in the memory. Instead, they will see 1 is 48 plus 1. So 49 is the ASCII value. So they will store 49, 50, 51 for 1, 2, 3. So when I say the ASCII value, 41, 43, that's the decimal. So convert to the hex. They are 31. Or we say 31, we don't say 31. 31, 32, 33, that's in the hex value. So that's why here we show you the example if you have a number 65. So how you will have the 65 display. Okay, so we have the 65. Okay, so how you want to display this 65 is all according to how you want to display when you do the cout. So sometimes maybe they just fill up is the save the 65 in the memory. But according to this 65, we can do the pure binary. So that's why when you do the cout, you just do coutx. So they will display 65. But sometimes we can convert this 65. We can tell the computer we want to display in the binary number. So then actually they will convert into the 8 character for each binary bit. Or you want to display that's the decimal, right? So that will be the 2 bytes for the 65 number. You can display hex, so then they become 41. Or like earlier we said, you can do here is you want to display character, so then you just casting to the character. So then they will display A in the screen. So that's all according to what kind of format you want to display. So then the computer will convert before they display in the screen.